Everyone and welcome. In this video I'm going to give the definition of rational functions and we'll learn how to find the domain of definition of such functions. So first of all, I'll start with a definition in which we say that r of x is a rational function if simply r of x is given as p of x over q of x, where both p of x and q of x are polynomials. Of course, you can go and check my previous video and learn more about polynomial functions. Now let me continue with some examples. So first, if I take r of x to be 2x power 2 plus 7x minus 1 over x plus 1, this function defines a rational function because simply if you look at the numerator is a polynomial and the denominator is polynomial as well, which means that this one is a rational function. Other example, let me call it r2 of x. If I take 7x power 6 plus 12x power 5 minus x power 3 plus x power 2 plus 1 over any polynomial with any degree, let's say x squared plus x power 3 plus 1. This one also defines a rational function because simply the numerator is a polynomial and the denominator is a polynomial as well. And now after learning the definition of rational functions, we can learn, or we are ready to know how to find the domain of definition of rational function. And first of all, I'll start with one of the cases or one of the situations that we usually face in math, in which we cannot divide by 0, in which whenever we have a number over 0, this case is considered as undefined case. So for this reason, if r of x is a rational function given as p of x over q of x, this function is defined whenever the denominator, which is q of x, is different than 0. So q of x different than 0. So for this reason, whenever I want to find the domain of definition of any rational function, all what I need to do is to solve the inequality q of x different than 0, or make sure that the denominator is different than 0. Let me give some examples here. So if I take r of x to be 2x plus 1 over x minus 1, this one is a rational function and it's clear here that we have x minus 1 in the denominator. To compute the domain of definition, I need to solve the inequality x minus 1 different than 0. It follows that x different than 1, which means that this function is defined for all real numbers except 1, or x equal 1. Other example, let me take r of x equal 2x over x power 2 plus 5x plus 6. So here, similarly, we have in the denominator x power 2 plus 5x plus 6, the quadratic function. So now we need to make this quadratic function, or to solve this quadratic function, different than 0. Of course, we all know that whenever we have power 2 or more, the first step we always try to factor this equation to find the roots. So first of all, I will factor this equation, and the factors are 3 and 2, different than 0. Then using the zero product rule, which is a b different than 0, I can tell that a should be different than 0 and b different than 0, which means that to solve this equation, I'll say that x plus 3 different than 0 and x plus 2 should be different than 0 as well, which means that x different than negative 3 and x different than negative 2. So r of x is defined over all real numbers except the elements negative 3 and negative 2.